Okay, so today we're going to go over properties of limits again, but this time we're going to look at it from a different perspective, and we're going to do it graphically, okay? So we're going to use graphs to figure these out. And we kind of did this I did it the other day on a problem I went over with you guys. But here's the important things, okay? You gotta know these properties, okay? If you take the limit of a sum, it's just the limits of the individual functions. Same thing with subtraction. Same thing with multiplication. If you have a function and you're multiplying it by some number value, you can take that number and multiply by the limit of the function, okay? And then the quotient rule is the limit of the numerator over the limit of the denominator. I'm just kind of saying it in just kind of general terms, okay? And then if you have the limit of some function raised to a power, okay, then what you can do is you can take the limit of that function and then raise that answer to that same power, okay? And then the composition. This is the one that's tricky, okay? The limit as x approaches some number of f of g of x, okay? So x is approaching c, and x is inside this g function, right? And what we're going to do is we're going to see what is g approaching, and those are y values, okay? And that's what this is going to do. But these y values become the x values for f. So when we do this, we're going to have to look at the one-sided limits of this, okay, and see, okay, how is it approaching? Because how it's approaching on the y's is going to dictate how it's approaching on the x's, okay? And so we're going to come up with this limit, okay? So let's do a couple problems here. All right, so here's a graph of f, and here's a graph of g, and I want to determine whether the limit as x approaches 0 of 2 f of x plus 3g of x, and I forgot to put exists here. Okay, to know if the limit exists, then we have to look at the one-sided limits. So we have to look at the limit as x approaches 0 from the left of, and this is the work you need to show, 2 f of x plus 3 g of x. Well, this is really the sum of two functions. So this becomes the limit as x approaches 0 from the left of 2 f of x, and then plus the limit as x approaches 0 from the left of 3 g of x. Okay, so now this one, we have a constant that we're multiplying f of x by. So one of the properties is we can bring that out. So this is equal to 2 times the limit as x approaches 0 from the left of f of x. And then we're going to get this just from the graph of f. And then plus the limit, no, whoops, I'm sorry. Hold on, because there should be a 3 in front, right? Because this 3 times g of x, right? Let me fix that really quick. Okay, so this would be, because this g of x is being multiplied by a number 3, I can bring it out and take 3 times the limit as x approaches 0 from the left of g of x. Okay, so this is going to be equivalent to, all right, and it's going to be 2 times, and we can figure this one out. So limit as x approaches 0, so x is approaching 0 from the left. So we're approaching 0, here's 0, we're approaching it from the left. So that's just this constant line, right? So this is going to be 2. So this is going to be 2 times 2 plus, and then 3, because of the 3 right there, times, okay, we're doing the same thing, the limit as x approaches 0 from the left. So here's 0, we're approaching it from the left on this function, and so it's approaching 0. And so that'd be 2 times 2 is 4, plus 3 times 0, which is 0, so this would equal 4. Now, if the right-hand limit is the same value, then it exists, and it'll be whatever that number is, okay? Or it'll be 4 if they are both the same. So the limit as x approaches 0 from the right of 2 f of x plus 3 g of x is equal to, and I'm going to jump all the way to this one, okay? So 2 times the limit as x approaches 0 from the right of f of x plus 3 times the limit as x approaches 0 from the right of g of x. Okay, so this one is going to be 2 times, and if we approach 0 from the right, it's still going to be 2, right? We're over here on the right, to the right of 2, and we're approaching 0, so it's still going to be 2. And then plus 3 times the limit as x approaches 0 from the right. Okay, so we're to the right of 0, and we're approaching it, and it's also approaching 0, right? So this would be 2 times 2, which is 4, plus 0, so that would equal 4. Okay, so they're the same. Okay, so that means the limit as x approaches 0 of 2f of x plus 3g of x is equal to 4. And that's the answer to that one, okay? All right, let's do another one. Okay, so for this next one, we're finding the limit as x approaches -1 of f of x times g of x. So again, to do this, we have to look at the one-sided limits. So we have to look at the limit as x approaches -1 from the left of f of x times g of x. Okay, so when you have a product like this, you can take the limit as x approaches -1 from the left of f of x and multiply that by the limit as x approaches -1 from the left of g of x. So we just have to look at these one-sided limits to figure this out, okay? So -1 from the left of f of x. So for f of x, we're approaching -1. So right here's -1. We're approaching it from the left, and the y values are getting closer and closer to a value of 1. So this would be 1 times, you wouldn't have to have the parentheses there, okay? Same thing over here, -1 from the left. So -1's right here, okay? So we're approaching -1 from the left on the function, and it's approaching this open dot, which is at 1. And 1 times 1 is 1. Okay, so now let's take a look at the right side of this, okay? So what's the limit as x approaches -1 from the right of f of x times g of x? And that would be equal to the limit as x approaches -1 from the right of f of x times the limit as x approaches -1 from the right of g of x. And so this is where they ask you, because if you try to do this and you try to do it at 1 and you just try to do the multiplication without looking at the one-sided limits, that's where they get you on the AP exam, okay? So they're trying to see if you really understand what the heck this means, okay? And so -1 from the right, so we're going to approach -1 from the right. So this one would be 2. And then times, and then this one, -1 from the right. -1 from the right would be, here's -1, so we're going to approach it from the right, so that'd be 1. And this would be 2 times 1, which is 2. These aren't the same, which tells you that this limit doesn't exist, because these one-sided limits have to agree. The left hand limit and the right hand limit have to agree. So we know now that the limit as x approaches -1 of f of x times g of x does not exist. So I'm going to stress this. It's always going back and looking at the one-sided limits. If you try to do like a direct substitution, okay, and you plug -1 in for f, you get you get 1 times, and you try to do it for g, and you get 2. So you get 1 times 2, which would be 2. All right. So, but that isn't what the limit actually doesn't exist. The left side and the right side of this won't agree. They won't come together. Okay. All right, so let's go to the next problem. So we want to find the limit for this one. The limit as x approaches 0 of f of x over g of x. And so to do this, we need to do the one-sided limits again, okay? So this would be the limit as x approaches 0 from the left of f of x over g of x. And so when you take the limit of a quotient, okay, you take the limit of the numerator over the limit of the denominator. So this becomes the limit as x approaches 0 from the left of f of x over the limit as x approaches 0 from the left of g of x. Now, there's one thing that we can't determine, okay, is what happens when this becomes 0, okay? So we're going to take a look at that in this case, okay? So the limit as x approaches 0 from the left of f of x. So as you approach 0 from the left, this numerator is going to approach 2. So this would be 2 over, okay, and that would be positive 2, okay? And so how about the limit as x approaches 0 from the left of g of x, okay? So from the left of g of x, we're getting closer and closer and closer to 0. But just before we're at 0, what do you know about these y values? Well, they're positive. So this is getting closer and closer to the number 0, but that's going to be a positive 0, okay? And what does that mean when you divide by a positive 0? That means this is going to infinity, which means this doesn't exist, okay? And actually, I'm going to tell you this is probably incorrect, really. To be mathematically completely correct, you probably shouldn't even write that, okay? But I'm doing it to explain to you what's going on, okay? All right, so the limit as x approaches 0 from the right of f of x over g of x, and that'd be the limit as x approaches 0 from the right of f of x over the limit as x approaches 0 from the right of g of x. As we approach 0 on the f function, we're getting closer and closer to 2 for the numerator, positive 2. As we approach 0 for g of x from the right, okay, we're getting closer and closer to 0 again, but all of these values are all going to be negative because it's below the x-axis. So all of these outputs are going to be negative, and we're getting closer and closer to 0. So this would be negative 0, which tells you this would come out to be negative infinity. And whether these were an agreement on the type of infinity or not, anytime you have it's equal to infinity or negative infinity, that automatically doesn't exist, okay? So here's another example of the limit as x approaches 0 of f of x over g of x does not exist. Okay, and once again, all right, this is just to help us, that whether it's positive 0 or negative 0 is just to help us to determine what is the sign of infinity. Okay, is this one going to be a positive infinity or a negative infinity? A lot of people have a tough time with that. Okay, hopefully I'm explaining it well enough that you get it. All right, even calculus teachers at the high school level tend to have a lot of times a tough time with this. Okay, so it's understandable. All right, this is the one I've been waiting for. This is the one I really want to go over with you guys because this is the one that's really, really kind of hard to understand. Okay, so we want to we want this to approach -2, and we have a composition of functions. Okay, we need to look at the one-sided limits as we approach -2. So we need to look at the limit as x approaches -2 from the left of g of f of x. Okay, so this would equal the not limit. This would equal g of the limit as x approaches -2 from the left of f of x. Okay, so we're approaching -2, right? X is approaching -2. We're putting that in for this x, right? So we're approaching -2, but we're approaching -2, and it's getting closer and closer to 0. So this limit is 0, but okay, this becomes the input for g, which becomes another limit. So this is getting closer and closer to 0, but it's getting closer and closer to 0 from negative values of, okay? So right before it's 0, it's negative. That means that we need to rewrite this as the limit as x approaches 0 from smaller values of 0, so negative values of 0, of g of x. Okay, so let me grab another pen and I want to talk more about this, okay? So where is this coming from? This is coming because we don't normally do this, but it's because it becomes an input. We say the limit as x approaches -2 from the left of f of x, right? And that's equal to 0, but it's approaching 0 from values that are less than it. So that's why I'm writing this negative, okay? Right there. That's not determining a sign or anything. That's just telling me, okay, these y's are approaching 0 from less than 0, from below 0, okay? And because these are the outputs for f, and those become the inputs for g, that's why I'm writing this as x approaches 0 from the left, okay? I'm getting it from this limit right here. Okay, so now we jump over here and we just need to figure this one out, okay? And so as we approach 0 from the left, so as we approach 0 for g, as we approach 0 from the left, we're approaching 0. Now this one won't matter how we're approaching because it's the end number, okay? So if I was just asking for this, I wouldn't say it like this. I would just say 0, okay? Like this one is the end answer. So this one is coming out to be 0. Now, if we were to put that into another function, if we needed that into another function, then we would say 0 from the right because it was approaching 0 from the left and the outputs were approaching 0, but they were all above 0, okay? I know that's hard to understand. Hopefully you kind of get it, okay? So let's do the next one. Let's do the limit as x approaches -2 from the right of g of f of x. Okay, so that would becomes g of the limit as x approaches -2 from the right of f of x. So what happens to f when we approach it from -2 from the right? Okay, so -2 from the right. So here's -2. We're approaching it from the right. It's getting closer to 0, right? So the answer to this by itself would be 0. But again, that's going to go into something, right? So this right here, this limit as x approaches -2 from the right of f of x is equal to 0. Yes, but I need to know what side of 0 it's approaching because this output becomes an input. So these inputs are getting closer and closer to this value, which means they're getting closer and closer to 0 from bigger values of 0. So that's why we have the positive. So this is smaller values of 0, bigger values of 0, okay? So now we can rewrite this as a new limit. This becomes the limit as x gets closer and closer to 0 from the right of g of x. Okay, as we approach 0 from the right, okay, as we approach 0 from the right, this is going to come out to be 0. Now, if we were to use that somewhere else, it would actually be 0 with a little negative here, right? Because we're approaching 0 from less than 0. Okay, although right before 0, they were all negative. Okay, so we'd put a little negative here. For this one, they were all approaching 0 from being positive, right? So that's why we'd put a little positive here. Okay. All right. So these are an agreement, right? So that means this limit exists. And so the limit as x approaches -2 of g of f of x is equal to 0. And that's the answer to that problem. Okay. You're probably going to have several of that look something like this, these composition ones on tonight's homework. For this last problem, what I want to do is I want to do the limit as x approaches 0 of f of x plus 2. Okay, so we're not even going to use g in this case, all right? But this is a composition of functions. And there is another way to look at this problem and through transformations, but I'm going to look at this a little bit differently, okay? I want to look at this as a composition, and we're putting the function x plus 2 into the f function, okay? So again, we got to do the one-sided limits. Hopefully I'm stressing that enough that you don't miss this because you forget to do the one-sided limits. Okay, so the limit as x approaches 0 from the left of f of x plus 2, right? And this is going to equal f of, and we would just do the limit as x approaches 0 from the left of x plus 2. Okay, now if we do this, okay, we do a direct substitution, right? And we could put 0 in here, and you can think of it like that, okay? But we need to know how it's getting, I'm sorry, it's getting closer and closer to 2, all right? Because we could do a direct substitution and put 0 in here. 0 plus 2 is 2. But I need more than that, okay? So we have the limit as x approaches 0 from the left of, and I'm going to put parentheses around this, x plus 2. And we know this is 2, but how is it approaching 2? Right before it's 0, these are negative, right? So that means this x right here is just a little bit negative, right? Just a little bit negative, which would make this 2 a little bit less than 2, right? So we're going to be approaching 2 from values that are less than 2. So I'm going to put a negative, okay? Smaller than 2. Okay, so because of that, these are my inputs into the f function, right? So that means my x's, as I put them into f, are getting closer and closer to this 2 from underneath. So this becomes the limit as x approaches 2 from the left of f of x. Okay, and then that's going to be really easy to read. As we approach 2 from the left, okay, it's approaching this open dot right here, right? Because we're coming this way. We're approaching it from the left. And so we know the value is equal to 1. All right, let's do the other one side of that limit. The limit as x approaches 0 from the right of f of x plus 2. So that would be f of the limit as x approaches 0 from the right of x plus 2. Okay, and I know this limit, if I do a direct substitution, would be 0 plus 2, that's 2. No problems with that calculation. Okay, but because I need to use that as an input to the next function, I got to figure out how it's approaching 2. So these are a little bit bigger than 0, right? So a little bit bigger than 0 would make this like 0.1 plus 2. So these are going to be big. These numbers are going to be closer and closer to 2, but bigger than 2 because this x value is positive, okay? So this is going to be approaching 2 from the positive side of it, which means now normally we wouldn't do this, so I want to stress this. If we were just trying to figure out this limit, we wouldn't put the plus here, okay? It would just be a number value, but we're going to use that because this output becomes the input for f. So if the outputs are getting closer to 2 from bigger than 2, that means the inputs are getting closer to 2, and that means I need to write this limit as x approaches 2 from the right of f of x, and the limit as x approaches 2 from the right, well, I'd be on this little part right here, right? And so that would be equal to -1. And those aren't in agreement, right? They're not the same number, right? So what does that mean? That means this doesn't exist. So the limit as x approaches 0 of f of x plus 2 does not exist. Okay? And I'm going to give you, in this Ed Puzzle video, I'm going to give you a couple of former AP questions that deal with this stuff, okay? And I will be happy if we can get them right, all right? Because that means you're understanding some very, very technical things, okay? All right. Most calculus teachers wouldn't even bother teaching this because it's difficult. But I'm going to prepare you for the AP exam, all right, guys? Just trust me. We're going to be prepared for the AP exam, okay? All right, that's it for today. I have a Delta Math assignment for you to do, and that's it. See you guys later.